Welcome to Session 23, Timed Mixed Practice and Error Analysis. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to use a three-pass strategy on mixed timed work to locate the first invalid step in an incorrect solution and to choose a targeted check based on the problem's risk profile. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. A repeatable flow protects time and accuracy across unfamiliar mixed questions. The flow separates choosing, solving, and checking. Mark a difficult item and return without abandoning the process. Target the likely failure instead of rereading every line equally. The key distinction is this: use a three-pass strategy on mixed timed work. Then connect it to the second goal. Locate the first invalid step in an incorrect solution. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Pass 1. Classify, estimate difficulty, and capture quick points. Identify the object being changed and the requested result. Step 2. Pass 2. Solve medium items with a written target and method. Use a separate line so signs, units, and restrictions stay visible. Step 3. Pass 3. Return to long items and audit domain, signs, and context. Work efficiently without skipping an operation. Step 4. For error analysis, name the first invalid transformation before repairing later work. Whenever possible, verify with evidence independent of the original working. Signal 1 is negative distribution. Respond by remembering. Audit every resulting sign. Name the response before calculating. Signal 2 is squared equation. In that case, check for extraneous roots. The form tells you which tool fits. Signal 3 is contextual decimal answer. Remember, estimate magnitude and inspect units. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. A student solves -2, 3x minus 4 is greater than 10, as 6x minus 8 is greater than 10, then x is greater than -3. Diagnose and solve correctly. Restate the target and identify the most important part of the routine. The first move is: the first error is distribution. -2 minus 4 equals +8, not -8. This changes the form without changing the meaning. Next, correctly, 6x plus 8 is greater than 10. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Subtract 8. 6x is greater than 2. State what the transformed line tells you. Complete the argument. Divide by -6 and reverse. X is less than 13. This is part of the solution, not decoration. The final answer is: the first error is the sign of 8. X is less than 13. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. After squaring both sides, what final check is essential? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint: squaring can create false candidates. Use it to repair your setup rather than guess. An accepted answer is substitute into the original. Explain why it works and name the first step that would expose a common error. The central message is: use a three-pass strategy on mixed-timed work. Combine it with a discipline to locate the first invalid step in an incorrect solution. Finish by remembering to choose a targeted check based on the problem's risk profile. This turns a calculated result into a justified answer. Reflection: name your 3 most common errors and pair each with one fast check. Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes for diagnosis, repair, and verification. Keep the work readable, check it independently, and carry the routine forward.